All right, guys, DNS exam 1, problem number 44. They tell you in this problem that a population is increasing according to an equation that they've given you right here, where population as a function of time was given to you by this one right here. They said the population approaches a limiting value as time goes on. So right away there, they kind of tell you exactly what's happening here. We've got a function that is growing over time. And remember, this is a calculator problem, so there was nothing to stop you from putting that into your calculator and simply graphing it right off the bat, and that wouldn't have been a bad idea to do here. The strange thing about it is you probably needed to adjust your viewing window to be able to see anything of importance as you go through this thing. But if I recall, and I did this problem last night, when our time value here is low, for example, when time is equal to 0, this whole exponent becomes 0. E to the 0 power is equal to 1. This term becomes 5,500, and that 6,000 minus the 5,500 tells us that we're starting here with an initial population of 500. But as t increases, what happens here is that the exponent on e, because of the negative coefficient, gets smaller and smaller and smaller, and e to a negative power is going to approach 0. Multiplied by the 5,500, it makes this entire term approach 0. And then the overall value of the population is going to get closer and closer and closer to 6,000. So what we really have here is a function that increases very sharply at the beginning and then really starts to level out and look something like this. And because we know that e to a power it can never be negative, all right, and this is only going to be getting closer to 0 as we move on, that 6,000 actually does in fact become the limiting value on that population right there. So in effect, this curve has a horizontal asymptote right there at 6,000 that this thing is going to get closer and closer and closer to. Now, the other thing they're trying to drive at right here is when they talk about a population having a limiting value, they're basically just asking you what's the limit as t approaches infinity of that function. And you can check this with the graph. You can check this on your calculator by simply putting in this limit on a calculator page, and we are in fact going to get 6,000. The question was, during which year will the population reach half of this limiting value? So half of that 6,000 value is going to get us 3,000. And that's the magical line here that they want to know when this thing is going to hit. So, a couple ways we could have done this. On your TI Inspire, you could have gone to menu 31 and simply done a solve equation here, where we could have set P of t, if you had defined that, or gone ahead and typed it out, is equal to 3,000 and solve that for t. Or we could have done it old school, the way you might have done it in Algebra 2, where you graph this function and you also graph the line y equals 3,000 and simply find the point of intersection right there of where those two hit. But in either case right here, we find that the population function is equal to 3,000 at a time when t is equal to 3.812, and that was measured in years. Now, that's the actual value of t, but the wording was a little bit funny. During which year will the population reach half that limiting value? So, this is one you got to think about for a little bit. At t equals 3, right on the nose, that means that it's been 3 years after this population started growing. As soon as you pass that third birthday, if you want to look at it that way, you are now in your 4th year. So this value of 3.812 actually occurs during the 4th year of this population increase, and that makes the correct answer C.